Hello everyone, welcome back to Lifesavers Academy. Today we're delving into a critical topic in healthcare, the pathophysiology of sepsis. Let's dive in. Sepsis is a life-threatening condition that arises when the body's response to infection goes awry. The pathophysiology of sepsis involves a complex interplay of the immune system, inflammatory response, and various organ systems. Understanding the pathophysiology of sepsis is essential for grasping the complex cascade of events that unfolds in response to an infection gone awry. It begins with the body's attempt to combat pathogens, triggering an immune response. In sepsis, this response becomes dysregulated, leading to an overwhelming inflammatory reaction throughout the body. Systemic inflammation releases an array of pro-inflammatory molecules, causing vasodilation and increased permeability of blood vessels. Consequently, blood pressure may drop, impeding the proper delivery of oxygen and nutrients to vital organs. As sepsis progresses, organ dysfunction may ensue, affecting the heart, lungs, kidneys, and liver. Coagulation. Dysfunction is also common, disrupting normal blood clotting mechanisms. This intricate interplay of immune response, inflammation, and organ dysfunction defines the pathophysiology of sepsis, emphasizing the critical need for early recognition and intervention to improve outcomes in this life-threatening condition. It all starts with an infection, which could be bacterial, viral, fungal, or parasitic. When the body recognizes the presence of pathogens, the immune system initiates a response to eliminate the invaders. The infection and immune response represent the initial stages of the pathophysiology of sepsis. When the body encounters an infection, whether bacterial, viral, fungal, or parasitic, the immune system springs into action. White blood cells and various immune cells mobilize to recognize and neutralize the invading pathogens. The immune response involves the release of signaling molecules, such as cytokines and chemokines, to coordinate the attack on the infectious agents. In a healthy immune response, these mechanisms effectively target and eliminate the pathogens, resolving the infection. However, in sepsis, this finely tuned balance becomes disrupted, leading to an aberrant and exaggerated inflammatory response that extends beyond the site of infection. This dysregulation sets the stage for the systemic complications that characterize sepsis, underscoring the importance of understanding and addressing these early immune processes for effective clinical management. In sepsis, the body's response becomes dysregulated. Instead of targeting only the invading pathogens, the immune system triggers an overwhelming inflammatory response throughout the body. The dysregulated response is a pivotal aspect of the pathophysiology of sepsis, where the body's immune reaction to an infection veers off course, becoming excessive and uncontrolled. Instead of targeted defense against invading pathogens, the immune system triggers an overwhelming and systemic inflammatory cascade. This dysregulation involves an exaggerated release of pro-inflammatory cytokines and other mediators, disrupting the delicate balance required for an appropriate immune response. The widespread inflammation leads to vasodilation and increased permeability of blood vessels, contributing to compromised blood flow and organ dysfunction. The dysregulated response in sepsis underscores the intricate challenge in maintaining a fine equilibrium within the immune system, as its imbalance can have severe consequences, emphasizing the critical need for timely intervention and management to restore homeostasis. Systemic inflammation leads to the release of pro-inflammatory cytokines and other mediators. While these molecules are vital in fighting infections, an excessive release can result in widespread inflammation, affecting various organs. Systemic inflammation is a hallmark feature of sepsis, reflecting the widespread and dysregulated immune response to an infection. In sepsis, the body's attempt to combat pathogens triggers a release of pro-inflammatory cytokines and other mediators into the bloodstream. These signaling molecules, including tumor necrosis factor alpha and interleukins, contribute to the systemic inflammatory cascade. While inflammation is a natural defense mechanism, the excessive and systemic release of these mediators in sepsis leads to a state of hyperinflammation. This heightened inflammatory state results in vasodilation and increased permeability of blood vessels, causing a drop in blood pressure and impairing the efficient delivery of oxygen and nutrients to vital organs. The systemic nature of inflammation in sepsis contributes to the characteristic multi-organ dysfunction associated with this life-threatening condition, emphasizing the complexity of its pathophysiology. The inflammatory response causes vasodilation, the widening of blood vessels, and increased permeability. This can lead to a drop in blood pressure and impaired blood flow, impacting the delivery of oxygen and nutrients to vital organs. Vasodilation and increased vascular permeability play pivotal roles in the pathophysiology of sepsis, contributing to the systemic consequences of this condition. In response to the dysregulated immune response, pro-inflammatory mediators induce vasodilation, causing blood vessels to widen. This dilation leads to a drop in blood pressure, compromising the efficient circulation of blood throughout the body. Concurrently, increased vascular permeability results in the leakage of fluids and proteins from blood vessels into surrounding tissues. This vascular dysfunction further impairs blood flow, preventing adequate delivery of oxygen and nutrients to organs. The combination of vasodilation and increased permeability contributes to the hallmark signs of sepsis, including hypotension and organ dysfunction. Understanding these vascular alterations is crucial for comprehending the severe impact of sepsis on the cardiovascular system and other vital organs, highlighting the need for targeted interventions to restore vascular homeostasis. As sepsis progresses, organ dysfunction can occur. Organs like the heart, lungs, kidneys, and liver may be compromised due to inadequate blood flow and cellular damage caused by the inflammatory cascade. Organ dysfunction is a profound and often severe consequence of sepsis, stemming from the complex interplay of dysregulated immune responses and vascular abnormalities. As the inflammatory cascade progresses, compromised blood flow due to vasodilation and increased vascular permeability contributes to inadequate oxygen and nutrient delivery to vital organs. Organs such as the heart, lungs, kidneys, and liver may experience dysfunction, impacting their ability to perform essential functions. The heart may struggle to pump blood effectively. The lungs may encounter difficulty in oxygen exchange. The kidneys may face challenges in filtration and waste elimination, and the liver may struggle with metabolic processes. Sepsis-induced organ dysfunction is a critical factor in the morbidity and mortality associated with this condition. Recognizing and promptly addressing these dysfunctions are central to mitigating the severity of sepsis and improving patient outcomes. Sepsis can also disrupt the body's normal blood clotting mechanisms, leading to coagulation dysfunction. This imbalance can result in both excessive bleeding and abnormal clot formation. Coagulation dysfunction is a significant component of the pathophysiology of sepsis, involving a complex disruption in the body's normal blood clotting mechanisms. In response to the dysregulated immune and inflammatory response, sepsis can trigger both excessive bleeding and abnormal clot formation. The release of pro-inflammatory mediators leads to a procoagulant state, promoting the formation of microclots throughout the circulatory system. Simultaneously, the anticoagulant system may be impaired, further contributing to an imbalance in the coagulation process. This coagulation dysfunction in sepsis can result in disseminated intravascular coagulation, a severe condition characterized by widespread clotting within small blood vessels, leading to organ damage and potential bleeding complications. Recognizing and managing coagulation dysfunction are critical aspects of sepsis care, as they directly impact the patient's risk of complications and overall prognosis. In summary, sepsis is a systemic response to infection characterized by a dysregulated inflammatory cascade, vasodilation, increased permeability, and eventual organ dysfunction. Early recognition and intervention are crucial to improving outcomes. If you found this information helpful, please like, share, and subscribe. If you have specific medical topics you'd like us to cover or questions about today's video, feel free to leave a comment below. Understanding the pathophysiology of sepsis is key to appreciating its severity and the importance of timely medical intervention. Stay healthy and see you in the next video.